Hello, welcome to Module 4, Extended Arduino Applications of APSC 2008, Digital Electronics and Computer Interfacing. Here in this module, we are pretty close to the end, and we are going to see some practical applications. And there are going to be 7 transducers that we'll be seeing in this module. So transducers are any devices that converts electrical energy into any other form of energy. So it can be heat or light or anything like that. So that is a transducer, or it could be the other way around as well. So anything that converts light, heat, or like sound, or like any other forms of energy into electrical energy. So those are called transducers. So a sensor is typically is a transducer which converts any other form of energy into electrical energy. Say for example, we have a microphone. A microphone will convert say the mechanical vibrations, like that when we talk, like there are some mechanical vibrations, so it'll take that or pick up those vibrations and then convert that into a electrical signal, and then like that was amplified, and like that's what we use we might use a digital processing circuit to store them, or like we convert that back into a amplified electrical signal connected to a loudspeaker, and then we use that in say PA devices, actually, things like that. So those are transducers. So just understand the meaning of what a transducer is. So we are going to see 7 transducers here. So we'll start off with the tilt sensor, and we will talk about buzzer, so which is a piezoelectric sensor. So unfortunately we don't have a microphone or something like that, so this is similar to that. The working principle is like very similar, but like here again, the buzzer, it converts the electrical signals into an output. So we'll talk about that. We'll talk about color theory in RGB LED. So it's just like a single LED with 3 LEDs kind of built into it, RGB. So there are 3 LEDs, and by changing the intensity of those LEDs, like we can produce like whatever color we want in the spectrum. And we'll also talk about like capacitive touch sensors. So the technology, or like say the technique, is very similar to how our smartphones work. But again, like we'll work with something like really primitive, and we'll talk about that sensor that is included in your kit. And we also talk about ultrasonic sensors or proximity sensors, like which uses ultrasound to know the distance of nearby objects. We'll do that. And we'll also use a stepper motor, how to control that. So stepper motor is typically an output. Again, this motor is like quite different than other motors. So we also use servo motors for electronics application, but stepper motor is like you can kind of precisely control its position. Although here in this course, we will not be precisely controlling its position. We will just like be we'll try to rotate it, like say clockwise and anti-clockwise direction. We'll try to change the direction of rotation. We'll try to change the speed. We'll do like how we operate a typical motor. But again, like you can precisely control these stepper motors if you want it. But like we'll not dig that deep in this course. Likewise, we'll also do an LCD display. So we did measure the temperature and humidity in the previous chapter. Let's say if you wanted to display, so the way we did that there was we used a serial communication to communicate between the sensor and or like the Arduino and the computer, and then like say the computer, we used the serial monitor to see what was going on. But here what we will do, like say in some situation like where you don't have access to a computer, then how would you display that information? So for users, like say they might have to display that, like let's say if you wanted to have a system at your home that displays the information, so we need to display that information then and there. So we use an LCD display. So here in your kit, like there is a LCD display that can display 2 rows of 16 characters actually. So we have an LCD display included in your kit. We will be using that and see how to program that and display some useful information there. So that is the 4th module. We will wind that up, and then following that I'll be posting some more videos towards the later part of this what to say this week actually. So where you get to see how we can operate GPS and things like that. Again, that is not part of the course, but like if you're curious to explore other options or like say GPS and other like complex applications, like you can watch those videos. If not, you can just ignore it. Like that's completely all right. If you just wanted to for the assessment, like you will not have any questions from those parts, but again, whatever we cover in this module will be it. So let's go and see the outcome of this course. By the end of this module, you will be able to comfortably build any circuit with a breadboard. So because we will be executing each and every circuit and every sensor like we'll be using in this course, so you will get really comfortable with the breadboard and you will understand and utilize tilt sensors, any piezoelectric effect sensors, touch sensors and ultrasonic sensors. You will get the basic understanding of this, and most sensors like will operate in a similar principle. So you can definitely use this knowledge to operate other sensors as well, or make use of other sensors as well. Likewise, we will be exploring RGB LED and we will try to produce any color in this spectrum, and we will see how that works, and then we will try to control stepper motor and display some strings in an LCD. And let's get started with the tilt switch or a tilt sensor. So this sensor is used to detect orientation or inclination. So that's what this sensor is used for. And the sensor we use here is called a ball sensor or like a ball switch. So inside, like it is a metal can. It has two terminals in the bottom. And the ball is a metal ball, like which makes contact if it was in a upright position. If it was tilted or if it was like inverted, like then the ball is not connecting. So again, like I said, metal can, like although outside it is metal, but like inside it is still an insulator. So if you tilt it or like if you invert it, so it is not going to make the contact. So no current flows through the switch. So this is a very simple switch. So the operation is like very simple as well. So let's see the program which we will be using. I'm not going to use the same program, but like let's bring in the Arduino IDE and just program this and see what happens. So I will also show my circuit. So let's get started with the circuit and then like we'll come here. So here is the circuit. We didn't talk about something called a pull-up or a pull-down resistor in the previous modules actually. So resistor serves another purpose. So in a condition like this, so we are going to program and see, like say if you read, we are going to of course like use a digital pin, and if it is high then you're gonna say that like okay, say do something, turn on an LED or something like that, and if it was low, turn off an LED. Like we have done programs like that before. So we didn't talk about something called a pull-up or a pull-down resistor. So you should not leave a pin hanging, and when you try to read, there might be a lot of other things like that is going on. So it should either be connected to 5 volts or 0 volts actually. So a pin like this will open, so like the sensor like this will open a circuit, but it will not connect it to ground. So what we will have to do is we will use a resistor, and either we pull up to 5 volts or pull down to ground, and then keep it in that state. And like this switch will kind of either apply 5 volts or like apply 0, and then like it'll change the voltage so that we can read that. So you can't leave a pin, digital pin, which you're reading just open. That's not going to happen. Okay, so that's what we'll do. So we are going to pull down using a 10K resistor. So here I have a 10K resistor. I'm just going to connect that. I will bring some wires, and here I'm going to connect this to ground, and then I'm going to take another jumper wire. And usually when I do circuits, I kind of use these pins in the end so that like I don't connect to a wrong pin So I'm going to either use like 8 or 7, like let's use 8. So I'm going to connect this way. So if you see this circuit, I've connected ground to one end of the 10K resistor and the other end of 10K resistor is connected to 8. So if I read pin 8, it is going to read what? It is going to read 0 because it is connected to the ground. Although it is through a resistor, it's connected to the ground. So I'm going to use the tilt switch and connect it to the other end of the resistor. So what happens if you see where I've connected this? So this is the 5 volts and it is connected here. It is through the it is the other end, like, which is connected to the pin. So technically I'm connecting the tilt switch to the pin. So if this is connected, it'll provide 5 volts to the pin 8. If this was open, then it is connected to 0 through a resistor though, but like 0 volts will be applied to pin 8. So this is how you will design a circuit with something like this. So now let's get into the program part of things. So here is my circuit. So let's start with pin mode, shall we? So pin mode, we are going to assign, I'm using pin 8 and that is an input. So why don't we use the built-in LED, like which is connected to pin 13? I'm not sure if it's going to be visible. You know, why not? Like we'll also run another wire. I have a 330 ohms resistor. I'll run another wire and like say, so that like it's clearly visible. Sometime, like say this pin, the LED connected to pin 13 might not be clearly visible sometimes. So I'm going to just have another output circuit and just wire them. So I will use pin 7 for this. So I will do pin 7 as an output. So I will connect it to that. Take another wire and connect it to ground. I can probably take this ground and apply it here. Okay, just I want to make sure, yeah, the orientation of the LED. Okay, so here is my circuit. So here I don't want 13 now. I will use 7 as an output. And you know what? Like I'm gonna use serial as well. Serial begin and 9600 is the baud rate. Okay, so let's start by reading it. So my value is digital read reading 8, and if val equals high, then what you will have to do is digital write, what are we writing, pin 7 as high, which means when it's in upright position. So let me also write that in command upright. So when it is upright, then it is going to turn on the LED. Okay, so and I will do else statement, or should I'll use another else if maybe. Else if val equal to low. I could have used else, I'm not sure. I don't know if we'll use else if, so it doesn't matter though, because here again we just have two conditions. I'm not sure if there's those are the things, like we call them bugs actually, so you can fix those bugs later on. Like for some condition it might not be true, so you might need an else if. So I'm going to use else if anyways. So we'll use write if 7 and it's going to be low, and here we can call it tilted, or it is not upright, so it's tilted. Okay, now let's stay consistent. Okay, Let's run it. So that's not bad. Oh, okay. I need to again serial. I have wheel serial over as well. Oh, it's saving. Okay, let it save. For some reason, it's taking too long. Okay, sorry, my bad, actually. So there was another window that popped out. Oh, okay. We need, this is a bool technically. And one more thing I forgot was to send this information. Serial, println, and val. Maybe I'll just send that. Yep, I think that's good. Let's run that. Okay, I have connected my board. I'll just make sure. Yeah, those are connected. Did I do something wrong? Sorry. Okay, so let's upload them and hope you can see that. Okay. Okay, so okay, I'm still not good in adjusting stuff with mirror images actually. So okay, so let us go. I've uploaded them. I will move to screen 1 probably. Okay, now here is my tilt sensor. So yeah, so even this one is not so bright though. Okay, so this is when it is in upright position and it is not. And let's also see what we get here as an output in the serial monitor. Yes, it is printing, it is upright, and as soon as we tilt it, upright, tilt, upright, tilt, upright, tilt. So yeah, so you can see that. So this is how a tilt sensor works. So again, this tilt sensor is mechanical. It's not one of the greatest tilt sensors out there. So we have some with mercury, the liquid metal. So those ones are like even more better. I would probably, if you're using it for some good applications, I would probably suggest that. And for simple basic applications like this will be sufficient. And this should wind up the first section on the tilt sensor. And I have a assignment problem for you. So you will have to design a system with the tilt sensor, indicate the orientation to the users using serial communication and an onboard LED. So you can use like pin 13. So you will use digital read function. So here you will have to attach 3 things. So one is the code, and the second one is the screenshot of the serial monitor, and then the photograph of your execution, like what we see right here. So I would need to see something like this. So it can either be, again, like in the next one I've asked for, you can either like do a photograph or like a video. So if you're doing a video, just make sure you write the question number on that and like upload it in Brightspace. So again, like don't make a lengthy video, just like make something like really crisp, like maybe 10 seconds or something like that, just to show your execution. Okay, so that is sufficient for like assignment question 3. No, this is 3. We had 8 questions there, and like this is 3.9. Sorry about that, it's not 10. So I will just like fix that. And this should wind up the tilt sensor session. So the next one, I believe, like we are going to see about like the piezoelectric devices. So we will see how the buzzers work in the next section. See you there.